Hi all, today we're looking at tangents and touching circles. So by the end of this lesson you should be able to solve problems and equations involving tangents and circles. Let's just remind ourselves of what a tangent is. So a tangent to a circle touches the circle at one point, and very important, is perpendicular to the radius that joins the center of the circle to the point of tangency. So that means that any tangent we have will be perpendicular to the radius that joins the center of the circle to that tangent. Okay, so first off, we're going to look at how we can find the equation of a tangent to a point on a circle. So step one, we will need to find the slope of the radius that contains the point of contact. Step two, as the tangent is perpendicular to the radius, we can then find the slope of the tangent. And step three, find the equation of the tangent from this. Okay, so I'll keep these steps up. Let's look at an example. So we're asked to find the equation of the tangent to the circle x squared plus y squared minus 2x plus 4y minus 20 equals 0 at the point of minus 2, 2. So we have a circle and we have a tangent at the point of minus 2, 2. You are looking for the equation of this tangent. So we need to find the equation of a tangent. So we're going to use our formula to find the equation of a straight line. So if we want the equation of the straight line, we use our formula y minus y1 So that's y minus y1 is equal to m times x minus x1. So to find the equation of tangent, we need a point on the line, which we have, but we also need to find the slope of this line. So in order to find the slope of the line, we find the slope of the center to a point that's on your tangent, and because we know that the radius here is perpendicular to the equation of the line, we can find the slope of the tangent from that. Okay, so let's go ahead and work it out. So step one, we're going to find the slope of the radius that contains the point of contact. So to find the slope of the radius, we write down our 2 points. So the slope of the radius is given by the point x1, y1, which is the center, and the point that's on your circle, call that x2, y2. The slope of the radius is given by y2 minus y1 over x2 minus x1. This gives us 2 plus 2 over minus 2 minus 1, which equals minus 4 over 3. So we find the slope of the radius. We know that the slope of the radius is perpendicular to your tangent. So to find the slope of your tangent, we flip our slope of radius and change the sign. So the slope of our tangent is equal to 3 over 4. So we now have the slope of the tangent and we have a point that is on your tangent. And we can use this to find your equation of your tangent. Okay, so we know that our slope is equal to 3 over 4. And we know that our point on our line is 2, 2. So to find our equation of our tangent, we use our formula y minus y1 is equal to m times x minus x1. Substituting our points into our formula gives us y minus 2 equals 3 over 4 times x minus 2. And rearranging our equation, so I'm going to cross multiply by 4 there, which gives us 4y minus 8 equals 3x plus 6. Bringing everything to one side of the equation gives me 3x minus 4y plus 8 plus 6, which is equal to 14. So our equation of the tangent is equal to 3x minus 4y plus 14 equals 0. Please pause and take down this example. Okay, let's try another one. We want to find the equation of a tangent from a point outside the circle. Step 1. We must find the centre and the radius length of the circle. Step 2. Let the slope of the tangent be m. Step 3. You will find the equation of the tangent using m as the slope. Remember that you will have a point on the tangent, and you'll write your equation in the form of ax plus by plus c equals 0. Step 4. Find in terms of m the perpendicular distance from the tangent to the circle and set this equal to the radius length. And then we'll solve for m. Step 5. Rewrite the equation from step 3 using your value for m. Okay, please pause and take down these points, and then we'll try a question. So we're asked to find the equations of the tangents from 1, 0 to the circle x squared plus y squared minus 12x minus 10y plus 51 equals 0. All right, let's just draw out what we're looking for here. So our point is 1, 0, and I have my circle. This point is lying outside the circle. And I want the equations of the tangents that go through this point. So here's my center. So I want this equation of the line, and I want this equation of the line. So we can see here that we will have two equations of the line. That means we'll have two different slope values that contain the same point of 1, 0 and are tangent to your circle. Okay, so remember, to find the equation of a tangent, we know that your equation of the tangent is a straight line. Y is ax plus by plus c equals 0. And to find your equation of the tangent, we can use the formula y minus y1 equals m times x minus x1. Okay, so our equation of the tangent, substituting in our point of the line, gives us y minus 0 equals m times x minus 1. So our equation of our tangent is equal to mx minus y minus m equals 0. So I just have to find my slope, and then I'll be able to find my equation of the line. Okay, so how will we find the slope? We know that our radius is perpendicular to the tangent. If I can find this point on the line, then I can find the slope of my radius and therefore the slope of the tangent. To use this, I will use my perpendicular distance formula. So my radius is equal to the square root of g squared plus f squared minus c, where g is equal to 6, f is equal to 5, and c was equal to minus 51, given here. Okay, so this gives us our radius as the square root of 6 squared plus 5 squared minus 51, which is equal to the square root of 10. Therefore, the perpendicular distance from the centre of your circle 6, 5 to your tangent mx minus y minus m is equal to root 10. So I can substitute these points into my perpendicular distance formula, where a is equal to m, b is equal to minus 1, c is equal to minus m, and your perpendicular distance is equal to your radius of root 10. Okay, so substituting this into my perpendicular distance formula gives me the absolute value of m times 6 plus minus 1 times 5 minus m over the square root of m squared minus 1 squared is equal to root 10. Okay, and from here I want to solve my equation. Okay, so the first thing we're going to do here is just simplify what's inside my absolute values. So this gives me 6m minus 5 minus m, which leaves me with 5m minus 5. And then cross multiplying gives me root 10 times root of m squared minus 1 squared. Okay, so we want to solve for m from here. So I'm going to square both sides of my equation to get rid of my square roots. So this leaves me with 25m squared plus 25 minus 50m is equal to 10 times m squared plus 1, which gives me 10m squared plus 10. So just doing that out here at the side. So this gives me 5m, 25m squared minus 50m plus 25 is equal to, squaring both sides leaves me with 10 times m squared plus 1. And then tidying that up, we're left with 25m squared minus 50m plus 25 is equal to 10m squared plus 10. And from here I want to solve for m, so I'm going to bring everything to one side of my equation. This gives me 15m squared minus 50m plus 15 equals 0. And now I want to solve for m, so I'm going to divide everything by the highest common factor here. So I'm going to divide everything by 3 first. Sorry, I'm going to divide everything by 5 first. This leaves me with 3m squared minus 10m plus 3. And to find m, I now factorize my equation. This gives me 3m minus 1 times m minus 3. Putting both brackets equal to 0, we're left with m is equal to 1 over 3, or m is equal to 3. I've now found my two slopes. So I find my two slopes for my equation of the line, so for my tangents. And from this, I can find my equation of the line. So my equation of the line is mx minus y minus m equals 0. Substituting in both values for m gives us, when m is equal to 1 over 3, your equation of the line is 1 over 3x minus y minus 1 over 3 equals 0. And then multiplying everything by 3 here to get rid of our fraction. So if I just multiply everything by 3, we're left with x minus 3y minus 1 equals 0. And when m is equal to 3, our equation of the line becomes 3x minus y minus 3 equals 0. Okay, so when you're trying to find the equation of a tangent when the point is outside the circle, you must write your equation of the tangent in terms of m, find the perpendicular distance between the center of your circle and a point that's on your tangent, i.e. find the radius distance. Substitute your equation of the tangent in terms of m and your point into your perpendicular distance formula and solve for m, your slope. Then substitute this back into your equation of the tangent.